So in this talk, I'm going to look at an experiment called the Large Hadron Collider Beauty Experiment, or LHCb for short. This experiment sits on the Large Hadron Collider in Switzerland, and it consists of about 700 scientists. Now this may seem like a large number, but it's nothing compared to the 3,000 scientists that work on the ATLAS experiment, for example, which is also at the Large Hadron Collider. The beauty in the name, so it's called Large Hadron Collider Beauty Experiment, comes from the fact that it's designed to look at the decay of a specific type of particle, something called the beauty quark. Now, in a video I put online a while ago, I said there were 6 types of quarks in the standard model of particle physics. The up quark, the down quark, strange, charm, top, and bottom. It turns out the bottom is also called beauty, so the bottom quark is the same as the beauty quark. One of the things that has been in the news about the Large Hadron Collider beauty experiment is its test of something called Lepton Universality, or a test of whether Lepton Universality is violated or not. Lepton Universality says that the certain particles in the standard model called leptons, which are defined as those which don't interact by the strong interaction, interact with the other interactions in a way which is independent of their flavour. Now the flavour is basically whether that electron is an electron, a muon, or a tauron. So it's basically said that those three interact with the weak force and the electromagnetic force in the same way in the standard model, or the same way in whatever model you are using to model your universe. A way to test this is to look at the decay of certain types of particles. And the way the Large Hadron Collider beauty experiment did this is to look at the decay of a particle called the B plus meson. Now this is a composite particle. It's made up of 2 quarks. And this can decay into another composite particle called a kaon. When it decays into that particle, it can either give out an electron and an anti-electron, also called a positron, or a muon and an anti-muon. Now, if Lepton universality held, those 2 events should happen with equal probability. This is what the Large Hadron Collider beauty experiment, or LHCb, tried to measure. And after run 1 of the Large Hadron Collider, they measured that this was different from the standard model, with quite a large significance. But after run 2, the result was much closer to the standard model. If you combine them, actually the significance of how far it was away from the standard model didn't change much compared to what it was at run 1. So the jury is kind of still open of whether LHCb saw Lepton universality or not.